Okay, pause the video and write down Theorem 12 in this example. Pause, 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 right. Okay, so very useful theorem. If you have a pivot for every row, then you are on 2. If you have a pivot for every column, then you are 1-to-1. So let's use this in an example down here. This is written strangely. I do so because I believe your textbook occasionally uses this notation. Okay, I would much prefer writing it like this. Plus, so vertically, like so. But the book is trying to save space, I imagine. So they write it horizontally, like so. Okay. Want to prove or decide whether it's onto or 1-to-1. First thing I'll do is try to use Theorem 12 here. Theorem 12 talks about a matrix, so I need to express this guy here as a matrix vector product. So I can write that as x1 times 3, 5, 1 plus x2 times 1, 7, 3, and that is the matrix vector product. So here's my A. So I'm just going to check to see whether it has a pivot for every row and or pivot for every column. A does not have a pivot for every column. Row for every row. How do I know? Well, it's got 3 rows and 2 columns. Okay, so the maximum number of pivots I have, it's a 3x2 matrix. The maximum number of pivots I can have is the smaller of these 2 numbers. Since what? 2 is less than 3. What about for every column? Well, if I do a quick little reduction here, exchange row 1 and row 3. Okay, I hope you'll agree. I will have something like this. Something like this eventually. So 2 pivots. Therefore, pivot for every column. So I have a pivot for every column, but not for every row. Therefore, T is 1-to-1, but not On to